So I'm sure everyone has heard of the term black hole once in their life, whether it be from a book or movie or just a point in conversation. But do we know what they actually are? By definition, a black hole is a region of space having a gravitational field so intense that no matter or radiation can escape it. Well, now you may be wondering how black holes are formed. Well, the first thing that you need to understand about black holes is that there's 3 different types of black holes. The first type of black hole is called a stellar black hole. They're formed when a massive star collapses, specifically a red supergiant. So the death of a red supergiant occurs when the core collapses in on itself and sends the outer layers exploding as a very large supernova. Your next question might be, how would a star collapse? Well, a normal life of a star consists of a constant battle between the gravity pulling in and the energy and pressure inside the star pushing out. The nuclear reactions within the star normally produce enough energy and pressure pushing out to balance the force of the gravity pulling in. However, in stars larger than our Sun, there is an increased amount of energy at the core which allows them to fuse heavier elements until they reach iron. The fusion process of iron, unlike all the other elements before, does not generate energy. Therefore, the core of the star would continue to create this abundance of iron until the energy inside the core and the gravity outside are imbalanced. Gravity would then take over, forcing the star to collapse under its own weight. The core material then packs together to become a black hole. They're about 3 to 10 times the Sun's mass. Black holes in essence have 3 layers: the outer and inner event horizon and the singularity. The event horizon is the boundary around the black hole where light can no longer escape. Once a particle enters the event horizon, it cannot leave. That is the point of no return. The particles are bound to the event horizon because of its constant gravity. The only way to escape the event horizon would be to travel faster than the speed of light, which is impossible because of the special theory of relativity. Sorry, Flash. The singularity is the inner region of the black hole where its mass is located. It is the sole point in space-time where the mass of the black hole is fixed. The second type of black hole is called a supermassive black hole. What a creative name, right? Well, they can have the mass as large as 1 billion suns, and they exist in the center of galaxies. Fun fact, the supermassive black hole in the center of our galaxy, the Milky Way, is called Sagittarius A. It's called that because it's located near the borders of Sagittarius and Scorpius, the constellations. The third type of black hole is called a miniature black hole, and they're really peculiar because no one has ever discovered one. They're hypothetical tiny black holes that would have the mass smaller than our Sun and are assumed to have formed following the Big Bang. Now let's go back and talk about the special theory of relativity. What's that? Well, in essence, it proves that the speed of light is constant no matter the inertial frame of reference of the observer. You can look at it in terms of speed equals distance over time. If the speed of light is constant, then distance and time must vary to accommodate for the speed of light. So time is only relative? Well, if you were traveling almost at the speed of light, time would slow down for you. If you were at the speed of light, time would stop altogether. Therefore, following this logic, if you were traveling faster than the speed of light, time would have to go backwards. As an object were to approach the speed of light, it would increase in mass as opposed to its speed. And it would take an infinite amount of energy for it to reach the speed of light, considering photons are essentially massless themselves. Interesting. Another interesting property of black holes is the relativity of time. If someone were watching you fall into the black hole from the outside, they wouldn't see you cross the event horizon. Instead, it would appear as if you were slowing down. You would slowly get dimmer and redder until you disappeared from their sight completely. However, what you would observe is a fast motion of the universe going by. Now, what would happen if a person were to fall into a black hole? Well, the theory is they would stretch out like spaghetti, because since gravity gets weaker the further they are from the mass, assuming that the astronaut is going feet first into the black hole, the gravity exerted on their feet would always be greater than the gravity exerted on their head. And because of this difference in force, gravity would literally tear them apart before they even reach the event horizon. Now, this theory holds true for smaller black holes. If you were to fall into a supermassive black hole, you could potentially live out your entire life before you even reach the singularity. Now you may be wondering what's inside a singularity. The short answer is we don't know. However, there is some interesting speculation that inside the singularity could be a bridge between universes, so a wormhole of sorts. Thanks for watching my video. I hope you learned lots about black holes.